Hello everyone, welcome back to che205. In this video, I try to continue talking about integration, numerical integration, and I would like to finish the Gauss Quadrature. So Gauss Quadrature is the third way to calculate an integral numerically. This is section 4.2.3 on page 88 of the textbook. Alright, so according to the Gauss Quadrature, if you want to calculate the integral of from -1 to 1 of f of x, then all we do is we evaluate this function a couple of times depending on the accuracy of the method we want to perform. For every evaluation, we have a point, let's call it xi, and we have a weight for that evaluation. So what we do is we substitute the evaluation point into f of x, and then once we get the f, we multiply by w, we sum over all the evaluation points. One thing which is really important about the Gauss Quadrature is that the limit of the integral should be from -1 to 1. If it's not from -1 to 1, we have to conform, we have to transform the boundaries or limits to be between -1 and 1. So here is a case where, let's say we want to integrate an f of x dx from a to b. Okay, instead of -1 to 1, assume it's from a to b. Then we can define an x. Okay, if let's say z in this case varies from if z varies from a to b, then x varies from -1 to 1 using this transformation, right? Again, if z varies between a to b, then x varies between -1 to 1, because when z is a, right, if you do the math for the numerator, if z is a, then the result would be a minus b divided by b minus a, you get -1. And when z is b, then we get b minus a over b minus a, which is 1. Okay, so this is the conversion from a to b to -1 to 1. So from now on, we only talk about integral from -1 to 1 because that's how Gauss Quadrature is supposed to work. All right, let's say I want to calculate the integral from, we directly go to the example. Let's say I want to calculate the integral from previous example right here, from 0 to 2 of pi 1 plus x over 2 squared and the whole thing squared dx using Gauss Quadrature. Okay, so first I notice that the limit is not -1 to 1. I have to conform the limit to be -1 to 1. So I have to use a change of variable to convert x to something else which only varies from -1 to 1. And in this case, the book actually did that and turned out to be this variable, so y. If y is 2x minus 2 divided by 2, okay, now if you simplify this, becomes x minus 1, right? In this case, when x is, let's say my x varies from 0 to 2, right? Let's go back to the original integral from 0 to 2, right? So here, let's go back to example 4.3. If x is 0, then y is -1. If x is 2, then y is +1. So you see that if x varies between 0 to 2, y varies between -1 and 1. And the conversion is exactly following this rule that we discussed here, right? In this case, the x is going to be, the z is going to be the x, and the x is going to be the y, all right? So you can plug in the a and b, and you see that that's the formula. Anyway, so now what we're going to do is we solve for x. So from here, x is going to be y plus 1. I'm going to substitute x by y plus 1 everywhere in the original integral. So the original integral was this, right? Now I'm going to substitute x by y plus 1 And of course, dx is also replaced by dy, because if you take derivative of both sides, dx, or differentiate both sides, dx is going to be dy. Anyway, so this is the integral, and the limit is going to be minus 1 to 1, where x was replaced by y plus 1. Now I can do Gauss Quadrature. So let's do, let's see. Let's do 4-point Gauss Quadrature in this case. That's what the book did. So for 4-point Gauss Quadrature, well, this is our choice. The more points we use, the more accurate result we get. So here's a table for the points and the weights. If you want to do 2 points, we have to use these values. Well, actually, this seems to be 2 values, because here it says plus minus. That means if you use this, you have to also use the negative of this. This is 3 points. 3 point means you have to use plus minus of this and also 0. Okay, so for 4 points we get, I'm sorry, actually I misinterpreted this. For 3 points we have 0 and plus minus 0.77. For 4 we get plus minus 33, plus minus 86. For 5 we have 0, plus minus 53, plus minus 0.90, and so forth, right? So everywhere you see a number has to be plus minus. Everywhere you see 0, there's just 0, because 0 doesn't have a plus minus. And these are the corresponding weights. Okay, if you want to do, let's say, a 4-point Gauss Quadrature, then we have to use plus minus 33, plus minus 86 with the corresponding weight. So let's go to that table. This is plus minus 33, and this is plus minus 86, and these are the weights that are taken from the table. Okay, just to check, let's say for, I'm sorry, these are the weights. For 0.33, the weight is 65, and for 0.86, the weight is 34. Let's go back. So, right, for 0.33 is 65, and 0.86, the weight is 34. Okay, so I have the weight sitting here. Then we evaluate the function. The function means the integrand, so I have to evaluate this integrand for these 4 values. You plug in minus 0.86 in here, you evaluate the integrand only. Then you plug in minus 0.33, you evaluate the integrand. You plug 0.33, evaluate the integrand, and 0.86. So these are the integrands evaluated with these values. These are the weights. Then we multiply weights by the function. Weights by the function, multiply these, you get this column. Then you sum them up, and you get the total integral. So that's the result. We can compare this 11.72 with trapezoidal rule, or, so this is trapezoidal rule, you see that's close, it's 11.77. And this, we also did Simpson, and it's the Simpson rule. No, we didn't. Okay, that's fine. So anyway, so it's close, and that's how we can perform Gauss Quadrature. So let's look at the example we did last time using different Gauss points. Okay, so let's go back to the example. This is the example we did last lecture. It's integral from 0 to 2 of, if I make it bigger, integral from 0 to 2 of 1 plus x over 2 raised to the second power, again raised to the second power, dx. And we want to do this using Gauss Quadrature. So first we notice that the limit is not minus 1 to 1. We have to conform the limit, and this is from the book. To conform the limit, x should be y plus 1, because when x is 0, then y is minus 1, and when x is 2, then y is 1. So the integral over y now is going to be minus 1 to 1. So all you do is you replace x by y plus 1 in the original integral here, and you end up getting this form. To move this a little bit around. Okay, so this is now the integral from minus 1 to 1, all in terms of y. Okay, so we're going to do Gauss Quadrature using, let's say, 2 points. For 2 points, I go to the table and get the 2 x values. For 2 points, you have plus minus 0.57 with weight 1. This is plus minus 0.57 with weight 1. So first we evaluate the function, that is pi times 1 plus, I'm just following this equation right here, pi times 1 plus y plus 1 raised to the second power, divide by 2, then raised to the second power, then raised to the second power, and that's what it is here. And I evaluate this for this y, then you drag it down, okay, you drag this guy down, you evaluate it for that value. Okay, these are the fy's, these are the weight, we just multiply them. Green times blue cell, and then you drag this guy down. And then this is the total sum of the last column. And that's going to be 11.69, which is very close to the other ways we did using trapezoidal rule. So this is trapezoidal rule from 0.5. I make it a bit wider. Right, this is trapezoidal rule with 0.5, trapezoidal rule with 0.2. We also did Simpson with 0.5 and Simpson with 0.2. And you see that, well, the most accurate so far is Simpson with 0.2, which is 11.72. And this one is a bit off because we use only 2 points. If you use the 3 points, then we get 3 points from the table. 3 points is 0 plus minus 0.77. So here is 0 plus minus 0.77, and the weights are, we go to the table right here, and the weights are 0.88 and 0.55. So here's 0.88 and 0.55 for the other two, right? We don't change this, the weight, the sign of the weight, only the sign changes for the y value. We evaluate the function f as before. You drag it down, right? And then you multiply f by the weight. So green times blue, you drag it down, you sum them up, you get 11.72, which is exact same thing for Simpson up to 2 decimal digits. 11.72 from Simpson, and 11.72 using Gauss Quadrature. But in this case, we didn't even split the interval. So that's the difference between Gauss Quadrature and other ways, like trapezoidal rule and Simpson rule. In this case, we never split the interval. We just evaluate at specific points. And these specific points can be found from this table. Okay, the points never change as long as the limit of the integral is from -1 to 1. Okay, we can go ahead and do the 4-point exactly like the textbook did, and the result actually doesn't change up to 2 decimal digits. You see 72, 72. Again, points are taken from the table, 0.86 plus minus and 0.33 plus minus. That's the 4-point, right? Oops. So 2 points here, 2 points here, 2 points here with the corresponding weights, 65 and 34. And the weights are here, 65 and 34. You evaluate the f again. That's the new f in terms of y, because y is between -1 to 1. And we evaluate f times y. You sum them up. And that's what you get. So this was calculating the integral using Gauss Quadrature, and important points to recap are, first, the limit should be -1 to 1. If it's not, we have to use the change of variable to conform the limits from -1 to 1, and then the formula for that is right here. If the integral is from a to b, if z varies from a to b using this transformation, then x varies from -1 to 1. Okay, then we apply the Gauss Quadrature to x value, to x variable, not to z, because x varies between -1 to 1. And the points are these, depending on the accuracy. If you want to do really accurate, we do 6 points, a little bit less accurate, and 5 points, all the way to 2 points. Okay? Whenever you see a number in the x column here, you have to also account for the negative of that. That's why it says plus minus. For 0, we don't have a negative, it's just a 0. And the weights for the plus minus are the same. So plus minus 0.70, 0.57, the weight is 1. Here the weight for plus minus 77 is 55. After we do the weight calculation, we multiply the f by the weights and we sum them up according to this equation. Alright, so that was Gauss Quadrature. Hope this is useful. Stay tuned for the last section of chapter 4.